One of the things I really love about the Haltech Nexus software programming system is its extreme versatility, flexibility, and customization. It really lets you as a tuner be in complete control of the tuning process in ways other engine management systems are a bit more limited. Engine safety is one of my top priorities when it comes to tuning, and there are a number of areas that you will want to provide protection protocols for. For example, wideband O2 lean out. When you're running wide open throttle and producing boost, it's critical that your lambda values stay close to your AFR targets. If things get too lean, it will lead to knock and put the engine in jeopardy. By way of contrast, let's look at how this is done in AEM Series 2. Here on the left, you've got options for the RPM minimum and the throttle position minimum. These are preconditions, how long it will delay it, and what's going to happen. We're going to kill the O2 and we're going to limit the RPMs to 3,500. With the graph at the right, the problem here is that you're limited to this two-dimensional graph. You've got load PSI on the bottom and you've got AFRs on the y-axis. You have no ability to change those. That's pretty much set in stone. And then basically you can only choose one option per time. So at 10.5 PSI, if my AFR is 12.8 or higher, then the protection protocols are going to come into place. Coming back to the Haltech NSP side of the equation, you also have preconditions that you can set up for a minimum RPM. Additionally, you can choose to have whether you want MAP, TPS, or both as part of the preconditions. So here we're going to minimum manifold pressure of 6 psi and a minimum throttle position of 50%, delay time of 700 milliseconds, and then most importantly, you have this DTV severity, which allows you to choose what level of severity this infraction is going to incur and what level of protection is going to be associated with that. Now, given those preconditions, we have options for what we can do with the wideband maximum. In one instance, it can be as simple as a one-dimensional table, which is to say that given these preconditions, if our AFR ever reaches 12 or higher, then we will enact the protection protocol in severity level 1. Now, while this may provide a basic level of quick and dirty protection, you're probably going to want to get a little bit more detail. And here's where the ability to set up your own table axis within Haltech NSP really comes into play. So let's say I want to add and make this into a 2D table. I can add target lambda. Let's stick some values in here from 10 to 14 AFR. Go ahead and accept those values. So we'll populate our table. So now we've got a two-dimensional table. And again, with our target lambda from 10 to 14, we can now go in here and put in some specific values that make sense. So let's say if our target lambda is 14, well, I'm going to give a little bit more leeway here, and I don't mind if we're 2 points higher. At 13, I also won't mind to go 15. 12.5, sorry, this would be 15. At 12.5, we'll go a point higher, and so forth. So as we work our way down the table, we can get closer and closer to our actual target AFR, so that as we encounter richer values, we're going to want to be closer to what those actual values are. The table can do something like this. So here when we're down at 10 AFR, we don't want to stray much further than 10.5. For 11 AFR, we want to stray not further than 11.5. But up here at 14, we can get as far as 2 points higher and not trigger the safety protections. Now, while this may be sufficient for most applications, you may want to go a step further and get even more granular by working with your table axis and setting up a third dimension. This is, again, the beauty of NSP, allows you to do this sort of flexibility. So we can add a third axis. We could use something like RPM. Maybe we want to go with TPS. Let's go with manifold pressure just to exemplify it here. So we have manifold pressure. Go ahead and add that in. And then let's give ourselves some values from 0 up to about 30 psi. If we drop that in, now our table has become a three-dimensional table. Let's swap the axes just to allow me to visualize this a little bit better. So now we're looking at our AFRs, target AFRs on the y-axis from 10 up to 14, and our manifold pressure from 0 up to about 30 psi on the x-axis. This allows us to get in here and get a lot more granular. So let's say if we're at 0 psi and our target is 10 AFR, we're not too worried about things if at this point in time maybe we're at 12 AFR. We're not going to necessarily need to trigger this disciplinary action that we would get. And maybe at 14 AFR, which is really basically stoichiometric, we're not really worried at all if we happen to be at 18 for a moment. Maybe we're in a decel fuel cut or something else. However, on the other extreme, when we're way out here at 30 psi, we really don't want to be very far from 14 psi if that would happen to be the target. And then down here at our target of 10 AFR at 30 psi, we'd really like to stay close to the bone there. So maybe it's 10.5. We take all these values and we just go ahead and linearize the whole table. We've got a nice table set up here which will really work to take into account both the manifold pressure and the target lambda in terms of what's going to trigger this level 1 severity action. Pretty cool. Now earlier when we were looking at AEM, we saw that the protection protocols were kind of limited in that you could cut the ignition and you could limit the RPMs. That's pretty much what you could do if the O2 went beyond the boundaries. Now we looked at it earlier here in NSP. We started setting up this wideband edge protection. We saw that we had DTT severities of levels 1, 2, 3, or none. And what does that mean for us? It allows us to use various protections at different places within the system. Let's go over here to engine protection. You can see how these are set up. So you can have a level 1 severity, which is your least severe, all the way up to level 3, which is your most severe. And within each of these, you can do different things. So you're going to have a level of fuel enrichment, target lambda enrichment, a boost correction, how many degrees of timing you're going to retard, and here's the rev limit. You can set this as you like it, and then you can auto reset this, and you can set this based on the active condition state. So again, the ability and the flexibility with NSP is pretty impressive in terms of the engine safety.